All right, chapter 12 is on linear regression and correlation. And chapter 12 technically has 6 sections in it. We're going to be kind of incorporating section 12.1 into the rest of the other sections. So 12.2 is about scatter plots. 12.3 is about the regression equation. 12.4 is testing the significance of the correlation. 12.5 is prediction. And 12.6 is about outliers. So let me try and give you a little bit of context for what we're doing here in this chapter. So first question is, why is linear regression and correlation important? So the answer is that people collect observations about something that interests them. So for example, we could be collecting data on hamburgers to determine if there's a relationship. So is there a relationship between calories and the composition of the burger, like fat and sodium? So what we do is we take, various burgers and we measure how much a burger from one restaurant, how much fat it has, how much sodium it has, and how much calories it has. Then we move on to the next restaurant and we get a burger and we measure its fat, we measure its sodium, we measure its calories. Move on to the next one. Next burger, measure its fat, measure the sodium, measure the calories, and so on. So we just conduct a lot of measurements from different burgers and measure the fat, sodium, and calories in each one. All right, now what you want to do with these random variables, so I should probably mention, fat is a random variable, sodium is a second random variable, and calories is a third random variable. So we have these random variables, and there's more we could have collected, but just to keep things simple, we got these 3. So now what we want to do is we want to see if there's a pattern in the observed data. Okay, so how do you set things up to look for a pattern in the first place? Okay, so looking for patterns is like looking up into the sky and you look at a cloud and you look to see if the cloud takes the shape of something familiar. But instead of looking up at the sky and at clouds and looking for shapes in clouds, what we're going to be looking at is we're going to be looking at graphs and looking for shapes in graphs. So we create what's called a scatter plot. All right, now with a scatter plot, what you do is you take 2 random variables. So for example, if we took fat and calories, and we plotted fat on the horizontal axis here and calories on the vertical axis there, then what you see is that we have ordered pairs. So for example, we have the point 19, 410, right? 19 on the x-axis, which is the axis that has the fat, and then 410 on the y-axis, which is the axis where we have calories. So if we come over here to 19, which would be here, and go up, and then we go from 410 and we go over, we can see that the point 19, 410 is this point right there on the graph. And so we've plotted 19 and 410. If we now plot 31 and 580, now let's see, 31, we can go up. 580 would be about here and come over, and that's this point. So you can see that this collection of points, let's see, my computer's acting a little slow. Come on. You can see that this collection of points are ordered pairs composed of the fat random variable together with the calories random variable. And that's in this scatter plot here. Now we can compose a second scatter plot, but not of fat versus calories, but now of sodium versus calories. So now what we do, kind of wanted to use a different color, but so now we want to put sodium on the horizontal axis, and we want to look at sodium versus calories. And so we look at one of these ordered pairs. So one of the ordered pairs we have is 920, 410. So we can come over to 920, which would be somewhere right about here, come up to 410 and come over. And that's this point right here. So that's the point 920, 410. And then we look at the next one, which is 1500, 580. So 1500, 580, that's this one. So we just go right on down the line, making ordered pairs of those two random variables. And what we get is we get a scatter plot of those two random variables together. So we get a scatter plot of sodium and calories, and we have this other scatter plot of fat versus calories. Okay. So now that we've got those scatter plots, what we want to try and do next is we want to identify a pattern or a trend. So when you look at the pattern, of these points on the scatter plot, you can see there appears to be a linear trend. The data points appear to be going up and to the right. So this is the analogous idea of looking in a cloud and saying, oh, it it looks like an elephant. Like, oh, that looks like a snow cone, right? Something like that. The scatter plot for sodium versus calories, it also looks like it could have a linear trend, but maybe going not so much up and to the right, but mostly just to the right. Okay. And this trend, we're trying to find a linear trend or a line that we could draw through the points. And we're looking for how that line is traveling. Okay. So now that you've identified a pattern, now you want to mathematically define that pattern. You want to mathematically define the trend. And so the mathematical definition of that line we call the line of regression. So you can see I've got the line of regression drawn in through our scatter plot. The equation that defines that line is this one, or this one here. So we have y hat is equal to 11.056x plus 210.95. So what that means is I can take any value of x. So I can take maybe 22, 24. I can take x equals 24, okay, which would be coming up from about this point. And if I put 24 in for x, then what I'm going to get out of it once I simplify it looks like a number close to 500. So I should get a number of 500 once I simplify all that. So this line of regression can be used as a tool to fill in the gaps in your data. But the only way you can do that is if you mathematically define it. Now, if we take the sodium versus calories scatter plot and we mathematically define this line of regression, then this is the mathematical definition of that line. Y hat equals 0.0996x plus 476.57. Now, something you should observe now that we've mathematically defined these two lines of regression is look at the first number here in front of the variable x. And what do you notice about them? The thing that we notice here is that this number here, okay, which is called the slope of the line, this slope is pretty close to zero. Whereas this slope is clearly not equal to zero. Okay, it's 11.056. This one is 0.0996. The slope is close to zero. And what you'll notice that this slope being close to zero, this line of regression is pretty close to horizontal. Okay. And this one where the slope is not equal to zero, the slope is not anywhere near horizontal. It definitely has a trend that's up and to the right. Okay, and that tells us something. So that's why mathematically defining the pattern is you get to look at these numbers and you can start to get something useful out of these scatter plots. And I already kind of hinted at this. So once you do this, you can use the pattern for a purpose. You can use it for prediction. So now that we have our line of regression, we can say, well, if we were to choose another burger and the burger had 26 grams of fat, how many calories can we predict that that burger is going to have? Well, you'll notice we don't have a data point at 26. We don't have a burger that we originally sampled that had 26 grams of fat in it. So how many calories is that burger going to have? Well, now that we have a line of regression that appears to fit, we can use it for a prediction. So if a future burger had 26 grams of fat, we would predict that it's going to have 498.406 calories, or close to 500 calories. And that's a real powerful thing to be able to say, that we didn't actually sample a burger that had 26 grams of fat, but based on our linear regression analysis, we could say that it's likely to have 500 grams of fat. And that's important. Now, this other one where we tried to see if there was a pattern between sodium and calories, it turns out that because our slope was close to zero, a correlation does not exist. And therefore, we cannot use it to do any predictions. And we'll kind of get into this in a little more detail, but it's only by doing this linear regression and correlation analysis of two random variables can you see if a correlation exists. Now, in the past, you might have learned, yeah, if you eat something that has a lot of fat, that means it has a lot of calories. And if it has a lot of calories, your body's going to store those calories in fat in your body, right? So you kind of equate eating fat is going to put on fat on the human body. But typically, you don't learn that if you eat something that's really salty, that it's going to cause, it doesn't mean you're ingesting a lot of calories and you're going to put on a lot of fat because you ate a lot of salty things. Usually, if you ate salty things, it increases your blood pressure. Okay, it has a different effect. But the effect it does not have is it does not add calories to your body. And you can see that here in the scatter plot when you look at the relationship between sodium and calories. Okay. So finding linear correlations between variables is something that scientists, engineers, health professionals, and even the average person does, even if they don't realize it. Okay. Well, I mean, of course, engineers are doing it on purpose. Okay. But the average person is kind of making those correlations. They're people or humans are pattern finding machines. We look for patterns in things. And sometimes the patterns we see are true, and sometimes the patterns we see are erroneous. But still, humans look for patterns in things. Okay. However, what we try to do as, scientists, engineers, health professionals is we try to look for patterns that are not erroneous, but are in fact true, that have a mathematical basis, that have an observed uh, reality, okay, have an objective reality to them, because we want to be able to design things based off of something that's true. Okay, so that's pretty much the process, kind of the 30,000 foot view of what we're doing here in chapter 12 and why it's useful. So let me stop this video here. Let me know if you have any questions.